Let's see highest response ratio next. The name itself says that we are going to find something called as response ratio, and now whichever process is having the highest of this, we are going to take it. So what is response ratio is waiting time plus service time by service time. So W means waiting time for a process so far, which means whenever you are standing at a point of time and till that point whatever is the waiting time, that is called waiting time, W here. So W is not the final waiting time, W is what is the waiting time at the point of your computation. So whenever you are computing it, at that point you find out the waiting time, okay, that is W. And then S is service time or the burst time. So S is nothing but the service time. Now for every process what we do is we find out this factor, and now among all the processes whichever is having this highest value we are going to pick it up, right? So here we are not purely depending on the burst time, we are depending on the burst time as well as waiting time. So how are we depending is, see, whenever this burst time is less, see this, whenever this burst time is less, yes, that will be having the higher value, fine. But along with that, if a process has been waiting for a long time, then that one will get the higher value, isn't it? So it is tricky, but then understand this. So if the job is having the shortest burst time, that is going to get higher value. Along with that, if the process is waiting for a long time, that will also get the higher value. So what is the main difference between shortest job first and this one is, in shortest job we were always taking the shortest possible job, but here we are taking both the burst time as well as waiting time, which means if a longer job, if a job with lot of burst time has been waiting for a long time, then that will also get scheduled, right, like this. And S is the service time, which means see this, HRRN not only favors the shorter jobs. Why does it favor the shorter jobs? Because denominator, there is service time, therefore lesser the service time, higher the factor, therefore it favors the shorter jobs, but also limits the waiting time of longer jobs, which means it will not let a job wait for a long time because because it is having a large burst time. With the examples it will be clear. Mode is non-preemptive. Non-preemptive means once we pick up a job, we are going to run to completion. So till a job completes, we are not going to let it go, right? So that is what it is. Now take this example and we shall see how to, how does this one works on this. Now at time 0 I am going to start it. At time 0 I am going to start the process P0 and I will be running it till completion. Why it is non-preemptive? Therefore at 3, now at 3 this process P0 gets completed. Now if you look at time 3, only one process has arrived by then, which is P1. Therefore I don't have any other choice, so I am just scheduling P1. And now what is it? So P1 is going to run for 6 units, therefore now the time is 9. Therefore by time 9 all the remaining 3 are available, 2, 3, 4 are available. Now which one should I pick among these? That depends on the response ratio, right? Now let's see the response ratio of each one. Response ratio of P2, process 2 is, what is the waiting time? It came at 4 and now the time is 5. Therefore what is the waiting time so far? 9 minus 4, which is nothing but 5, right? 5 plus, then what is this burst time? Burst time is 4 divided by 4, right, which is nothing but 9 by 4. I think you will get 2.25. okay, that is response ratio of P2. And now you can compute the response ratio of the process 3. So response ratio of process 3 is, waiting time is nothing but it came at 6 and now the time is 9, therefore it waited for 3, plus burst time is 5, therefore divided with burst time, right? Then what we get? We get 8 by 5, right, which is 1.6. 1.6, yes, okay. And the next one is response ratio of 4. You have to find out all the response ratios of the process remaining, right? And now it came at 8, therefore it waited for 1 because now the time is 9 and its burst time is 2, therefore 3 by 2 is 1.5. So these are the response ratios of second process, third process and fourth process. Which one is having the highest response ratio? This one, right? Therefore I am going to pick up the second process and schedule it. So P2 will be scheduled, and how long does it run? It will run for 4 units, which means till 13 it is going to run. Understood that? Okay, now the time is 13, and what are the process I have? 3 and 4. So now I should compute again the response ratios of 3 and 4. Response ratio of 3 is, it arrived at 6, now the time is 13, therefore it waited for 7 units, plus its burst time is 5, right, by 2, so which is nothing but 12 by 5, 12 by 5, so this is 2.5, 12 by 5, 12 by 5, I think it is 2.5, oh, 2.4, yeah. And now response ratio of 4.1 is, fourth process is here, it came at 8 and now the time is 13, therefore it is 5 plus what is the burst time? Burst time is 2 divided by 2, which is 7 by 2, 3.5. So 3.5 is very much higher, right? So 3.5 is very much higher than this value. Therefore, we are going to schedule P4 first. P4, and it is going to run till how much time? 5 units. Therefore, till 18, and then I am going to next schedule P3. That is the only job remaining. Now P3 needs how much time? P3 needs, if you observe it, 5 time, 5, right? Oh, P4 needs only 2 units. Therefore, it is from 13 it is going to run till only 15. Let me just check it. P0 requires 3 units, P1 requires 6 units, P2 requires 4 units, P4 requires 2 units, only 2 units, and then P3 requires 5 units, which means till 20, right? So this is how HRRN is going to schedule the process. Now if you want to see what is the difference between HRRN and shortest job first, let's see the Gantt chart for shortest job as well. This is the Gantt chart for HRRN, highest response ratio next. Let's see it for the other one as well, shortest job first. That will give you some insight about it. Now coming to this shortest job first. So initially nothing will change because only one process is available. So I am going to take it and schedule it. Nothing is going to change. And at time 3 only one more process is available. Therefore I am going to schedule it. Nothing is going to change. And P1 is how much? 9, right? At this point all the processes are available. Then if you use shortest job first, which one will be scheduled first? P4 will be scheduled, isn't it? Because among the remaining process, P4 is having the shortest one, right? And then what will be scheduled after P4? The next one that will get scheduled is P2. And then after P2, the next one that will be scheduled is P3. Therefore, if you watch it, the order in which they got scheduled has changed, right? Especially this P2, P4 and P4, P2, right? So even though P4 is having a higher, see this lower burst time, P2 is favored. The reason is P2 has been waiting for a long time. P2 has arrived at 4 and it is waiting till 13. Then it is better that you give it the chance. The reason is this: if a longer process has come earlier and it has been waiting for a long time, it is really unfair to give the chance to a shorter process which came very late, right? So therefore HRRN is going to have some benefits over SJF. Anyway, again here also the same disadvantage persists. What is this disadvantage? You cannot implement this because you want the burst times to be given well ahead. But then the problem is we cannot get the burst times. Therefore, it cannot be implemented practically, but theoretically yes. And maybe if you could guess the burst times by using some methods like process size, process type, or static dynamic, it is okay. You can implement it. But anyway, most of the operating systems don't use this. Round robin is the most favorable one. So, however, these algorithms which are based on burst times will give you the best performance possible, and they can be used to measure the performance against the others, which means they are nothing but you can think of them as the measuring scale. So they are going to be the some kind of scale and everything else is measured against it. If the performance of shortest job first is so and so, your algorithm is going to be this, so it is close to this, it might be best, like that, right? Fine. Let's compute the completion time, turnaround time and waiting time and finish it off. So completion time is this. So I'm talking about HRRN. So if you watch it, completion time is, since this is non-preemptive, you can go either from the right side or left side, not an issue. So completion time of P0 is 3 and completion time of P1 is 9 and completion time of P2 is 13, completion time of P4 is 15, completion time of P3 is 20, right? P3 is 20 and then completion time of P4 is 15. Let's check this. P0 is 3, P1 is 9, P2 is 13, P3 is 20, P4 is 15, right? And after finding out the completion time, we are supposed to find out the turnaround time. Turnaround time is completion time minus arrival time. So how much is this? Here it is 3 and here it is 7, here it is 9, here it is 14 and here it is how much is it? 7, isn't it? Okay, and then you can find out the waiting time. So what is waiting time here? So waiting time is turnaround time minus arrival time, which is 3. Turnaround time is burst time, which is 0 here, right? And then turnaround time is 7 and the burst time, so it is 1 and then it is 5, it is 9, it is 5, right? So this is the waiting time, and you can find out what is average turnaround time and what is average waiting time. And if you want to find out the response time also, you could find it out. See this, what is the response ratio of P0? It arrived at 0 and it got scheduled immediately, therefore response time is 0. What is the response time of P1? It arrived at 2 and it got scheduled at 3, therefore response time is 1. What about P2? It arrived at P2 arrived at 4 and it got scheduled at 9, therefore response time is 5. And then P3 arrived at 8 and it got scheduled at 15, therefore its response time is 7. And P4 arrived at 8, P3 arrived at 6. I'm getting confused only between P3 and P4, okay. P3 arrived at 6 and then it got scheduled at 15, therefore 6 and 15 is how much? 9, I think. Response time is 9. And what about this one? P4 arrived at 8 and it got scheduled at 13, therefore its response time is 5, right? So these are the response times. You can find out the average response time as well. Got it? So yeah, that is what I was saying. Response ratio in HRRN is better compared to SJF. Okay.